beaker of water contains 4.214 times 10 to the 24 molecules. How many moles of water are present? And we've got the Avogadro constant here. So this is a question about using the Avogadro constant. Now I think these questions are some of the easiest questions in chemistry and some of the hardest questions in chemistry. Let me try and put this differently. If I said to you, we've got 36 eggs, and I asked you how many dozen eggs you've got, you would say 3 dozen, because you would do 36 divided by 12. You know, 12's in a dozen, so you divide the two and you get 3 dozen. And pretty much every student I always ask can do that calculation for me because of what they know about a dozen, and 36 is a number that they can work with. It's a simple enough number for them to work with. This is exactly the same. This question is absolutely identical. It's just more difficult, and this is because the numbers are very large, much more abstract, times 10 to the 24, times 10 to the 23. But it is that simple. We need, a formula here. We could say, often in lessons we write the formula. Molecules, number of particles. Let's do that here. We will write the formula: number of particles, in this case they're molecules, equals moles times the Avogadro constant times the constant Avogadro constant. So that's our formula, and I know lots of students learn that, so let's rearrange that and we'll come up with the answer. We want moles this time, don't we? How many moles? So moles is the question mark, so that's going to be moles equals number of particles, in this case it's number of molecules, equals number of molecules divided by the Avogadro constant, in this case 6.02 times 10 to the 23. And that's exactly what we did here, didn't we? We did number of eggs, so instead of molecules we'd have eggs. And 12 is the constant, it's a dozen. Dozen is 12, so that's a constant. A constant is the name we give to a number. And that's what we've done in exactly this case. So it's exactly the same calculation, the numbers just happen to be a little bit bigger. So molecules, 4.214 times 10 to the 24, divided by 6.02 times 10 to the 23. I'm just looking at those numbers and I think the answer is 7, but let's put it in a calculator and just see. Okay, now the most important thing when doing this question is we put the number into the calculator correctly. So 4.214, that goes in exactly as you would expect. 4.214. Now, this is a bit people make a mistake with. This is not a multiply here. Okay, this is not the multiply button. It's not that button. It's times. This is the times 10 button. Now, on different people's calculators, it's called different things, but it's often down here at the bottom. Times 10 to the x. When I was a kid, my calculator, that button was called EXP. If you do it on an iPhone, it's called EE, but you can't have an iPhone in exams to get a scientific calculator. Times 10 to the x is the normal notation, so times 10 to the x. And then we're doing 24. Then we're doing divide. That's a standard divide, so that's the divide button there. And then 6.02. Okay, and this is the times 10 button again, not the multiply. So it's not the multiply, don't press that. Times 10 to the x, that's the button we're pressing. And then 23, if I'm right, is 7, which it is, 7, equals 7 moles. All these questions on elshamhighchemistry.com.